Hi, I'm Erik Linask. I'm here in Las Vegas, coming to you from CompTel, talking now with XKL's Len Bosack. Len, thanks for joining me. It's good to see you again.
Good to see you, Erik.
A lot of talk in general I would say over the past, say, six to 12 months maybe. I've been asking a lot of people about what's the state of the market when it comes to 10 gig, 40 gig, and really what I've been asking about 100 gig. You've got a little bit different take than some of the people that I've talked to who are really trying to push 100 gig.
Yes. The truth is that 10 gig has finally gotten to the point where it's 10 gig without drama. We can provide, certainly from XKL's equipment, day in, day out, continuous operation 10 gig, that clean your fiber, plug it in, it works, you move on to the next one. And you can do that again and again, and it just sits there and works. To go faster, right now, our modulation scheme is we just turn the light on and off. A wavelength division multiplexing system would be familiar to Marconi or DeForest. It's Morse code on multiple carriers. They did that in the 20s. So we have to do somewhat better than that. We started to try and do those blinking lights at 40 gig. Mm-hmm. Do you notice 40 gig didn't really take off? It's just too hard to do that sort of technically symbol rate, 40 gigasymbols a second. All sorts of imperfections in the fiber become apparent. You almost have to hand tune every link, and that's just too hard. It gets to be drama every time. So no one, as far as I know, knows how to make 40 gig blinking lights go very far without drama. So there was an attempt to go there. We've got some 40 gig links. It's good commercial stuff, but it's hard to do, and it's probably not something that people are going to do in a private network. To get to 100 gig, people just knew you couldn't get there. It wasn't going to happen. So we went to technology out of probably the mid-50s, which is what's called quadrature phase shift keying, and that's all they did. They populated both carriers, both polarizations for each color, and you can barely get 100 gig to go some distance if you turn the knobs to the right on the FEC, and you're not really going to build a long-haul system with this either. So our take on 100 gig is, well, if you're adventurous, you can do some this year. Better next year. It's going to be 2015 before it happens without drama. I know many people don't want to hear that because that's not what their next quarter's profits are built on, but here we are. It's probably, I certainly believe it. Our system and our long-term goal is to get a terabit down each color. And we have a 100 gig space system, and we know theoretically that we can do it. And we believe that practically we're going to be able to do that as well. So we've undertaken, our research work is aimed at many more bits per symbol, complex modulation, where we believe the future moves in an arc towards a terabit per carrier. Don't hold your breath on when you'll get that terabit per carrier, because everything becomes ever harder as each doubling of the speed has made things much, much harder. But on the other hand, if we do succeed in where we think we can succeed, we'll be able to get, for example, perhaps 50, 40 gig channels down a small number of transponders on TAT4 across the Atlantic. That's a big extension of bandwidth there. And we think we can do it, but not next year. So we see a future that is indeed bright, but not that soon.
What do we need a terabit pipe for?
Oh, just look at just look at the smartphones, all the little gadgets, and in any one of them, there's not an enormous amount of bandwidth. But when you have them by the tens of millions, there is a lot of bandwidth. And that's what's happened. That's one of the changes in the networking industry that our demand is now driven by large numbers of what we don't regard as very fast devices. But the weight of numbers is there. Now, why do you need a terabit in a single stream? Well, there are some supercomputer complexes that would be eager to have that today. Not at a price that it would take to get it, but they would, if the price were reasonable,
Right.
they'd be eager for it today. And in time, what is true at the high end does move down the scale in computing and in cost. So we're not going to run out of advance in computation anytime soon. Yes, it's happening because we're going from conventional computers to the general purpose GPUs, and it moves on. The architecture of these machines changes somewhat, but it enables enormously larger computations, which require, in some cases, enormously larger bandwidths. So, common application? No, not today, not in 2015. But will it happen? Yes, I believe it will.
But the market first has to figure out 40, according to what you're saying, or do they skip 40 and go straight to 100?
40 might make a comeback when you don't try and use on-off keying to go any distance. We can get 40 gig the last 10 or 20 meters without any trouble. What we can't do is get it across the city without any trouble. Can we do it? Of course we can do it, but without any trouble? No, sir. It's trouble. So with a more robust medium to long haul coding scheme, 40 gig may very well have a comeback.
Excellent.
The router interfaces don't cost $5 million a pop. Want a good 100 gig router interface today? Anybody been willing to tell you what the price was? Ask the question. What are they paying for not field test 100 gig router interfaces?
No idea.
The idea is more.
Excellent. Thanks, Len. It's been a pleasure as always. We've been here at CompTel talking with Len Bosack from XKL.
Thank you, Eric.
Thanks again for joining us.
Certainly.